Okay. Okay. Presentation. I want to make a presentation about building information modeling from my essay, which is BIM for architect and engineer. So, okay, we have 7 major discussion for today's presentation that have I think will address most of the topics in my essay briefly. So for the first one is BIM for architect and engineer. Second one is collaborative forms of project delivery. And the third one is BIM usage in design process. And the fourth one is BIM-based concept design. The fifth one is an example of integrated conceptual design. Sixth one, analysis, simulation, and checking. And the seventh one is BIM justification for design practice. There's these 7 major discussion, major topics, which is will be shortly discussed in subtopics that I have made. And hopefully, will address the topic that we'll be discussing. Okay, for the first one is BIM for architecture and engineer. For the summary for this topic is first one is what is BIM. Of course, we have to learn what is BIM, and then BIM for design. And there's 3 major perspectives, if I'm not wrong. And then there's the McLeamy graph, which will be which I will discuss with you because it's a very interesting line that shows us the difference between the traditional method and the preferred today's method. So what is BIM? BIM is to design and configure building model at the development phase with automatization building model detail. So it's not a regular CAD designing with line and two-dimensional model. It's a 3D modeling. Okay, and it's a method, not a software, because software is only tool for this BIM method. Because let's just say if there's a collaboration components in designing the project, okay, between the contractors, owners, and the architect, this BIM, let's say Trimble Connect by Tekla, it only bridges these 3 components in, let's say, communication, reviewing, and redesigning. So it's only a tool for them to use. Whereas BIM, there's more complicated. BIM is a whole method, not only for designing, but it's communication and automatization from modeling, cost estimating, and much more. Therefore, securing design and document consistency, spatial interference, building components checking, analysis, and communication through all building phase from what I just talked about. Next is BIM influence. Rated from 3 perspectives, there's this conceptual design and then the integration of engineering services and construction level modeling. Okay, so BIM influences rated from these 3 perspectives. Next one, there is this McLeamy graph. This graph indicates distribution of the design process. Line 3 and 4 indicates distribution of the design process, both traditionally and preferred method. As you can see, there's this graph 4, I mean line 4 and line 3 align with line 1 and line 2. Okay, this indicates that the traditional method or the line 3, which has the design process more in construction documentation or construction phase. So the cost, it impacts on the cost and time inefficiency. They still designing, still make review, still make revision in design process. So it's not worth the time, it's not worth the cost. Whereas because the automatization, because of the software tools and this BIM method, in today's method, the design process will be distributed and allocated to this line 4. Line 4 indicates that the design process will be much more take place in the schematic design and the design development, which is, if we align it with line 1 and 2, will be costing less, and still because of the building hasn't built yet, we can change the design without interfering with the design construction. I mean, with the construction phase. Whereas in the traditional method, when you're changing the design in the construction phase, when you changing the design that has been built, it will interfere with the time scheduling because you have to do it all over again, and that's costing much more and making more time to waste. Okay, so this is McLeamy graph. Next is the collaborative forms of project delivery. So if we summarize this topic, there will be three subtopics, which is design build, design build, and integrated project delivery, or we can call it IP. So this design build is traditional method of project contract, relies on partition of through two procurement processes, that is design and build. So they part those two processes. They design and they build, not in the same time. This method of contract impacts ineffective time and cost. Architect limited only to design, thus not obtaining further information from contractor about changes in design. Or we can say it less information thereafter. Contractor and architect not aiming in the direction of what the owner wanted because of inefficiency of the communication, because of the type of contract. So yeah, they avoiding things one and two things, so that contractor may more benefits with the changes in design and much more, if we want to discuss about this design with build contract. And there is this design build contract. This contract gives commercial communication between the owner and the service provider about the design and building process. But this method makes the architect a small part of building process. Okay, so because of these two major communication made only between the owner and the contractor, the architect will play in a minor part. But still, there's communication in the design and build between the owner and contractor. So, and there's this IPD, or integrated project delivery, that connects the owner, the contractor, and the architect in one collaborative contract, enabling every component to evaluate one another. This IPD lines and used in BIM mostly because what it's designed to be, BIM, so that three of these components could communicate, could collaborate effectively. So the design will be precise, and consistent. So there will be no change in the construction phase. And BIM used in design process. So there's this point of views in using BIM. For the first point of view, design conceptual design, determining the basic framework for development in the next phases. This is the most creative part of design activity and contains all aspects, such as function, cost, environmental impact, building practice, and aesthetics, and much more. If we can see the model that is presented in early meeting of a project group, we can see the conceptual building in 3D model. That is the conceptual design. It within changes, within the range of changes, reviews, and it gives the visibility to contractors and the owners, so they can talk in one direction, because sometimes two-dimensional model, it's a bit hard for them to communicate, because yeah, it's a planner, and sometimes 3D model has different on each levels. Anyway, let's go to the second point of view. The use of BIM for buildings, for building design analysis for many aspects of building functionality. For instance, structural integrity, temperature control, airflow, lighting, pedestrian circulation, etc. Because of the today's tools used in BIM, it automates the process for, let's say, calculating the structural integrity, temperature control, and airflow, and etc. So they can make some trial error and making the best option available in the design process. So yeah, not only, let's say, one. Let's say just that the consultant made one method of the building to be controlled by temperature, pedestrian, and lighting. Usually, they just agree and evaluate the value around that what the contractor has made, and this is very limited and not creative. And because of today's tool, I think it can be more creative and more vast than the traditional method. Okay, and then the third point of view is the use of BIM for building level information development. Building modeling software can accelerate deployment and documentation of construction standard, thus increasing building quality. Let's just say that 3D modeling has been made, and 2D of detail, 2D building detail can be made just by clicking, and it aligns with what the 3D models has been, let's say, accepted by owner and consultant. So there will be no interference, and that is not time consuming. And then next one is BIM based conceptual design. Is the conceptual design using software. So we talk about software in this BIM method, but what is the software used in conceptual design? The conceptual design usually involves the development and improvement of building program shown in the building layout, floor plan, mass, and general view. As you can see in the picture, there is this general view of the concept building. Then the software that generally used for the conceptual design of 3D building model is SketchUp, Rhinoceros, Bonsai 3D. You can see the left one is SketchUp, and then the right side is a Rhinoceros. There's this program usually used to make a conceptual design in 3D model. Pretty much sums the conceptual design in making a building model. Next one is an example of integrated conceptual design. There's this general service administration. An integrated design is the integration of many models from many software to achieve preliminary output through significant automated feedback for early stage concept design. For example, the U.S. Federal General Service Administration has design process that is defined in P100 PBS standard facility. The design guide identify many steps and feasibility before project selection and delivery to the architect. To pretty much sums it all, let's see this design guide by GSA. There is this Refit model, Bentley model, ArchiCAD model, and the other building model. Then there will be compiled in model property data by significant automate feedback for early stage concept design. Then we got the preliminary concept in space program validation, preliminary circulation and security assessment, preliminary energy analysis, and preliminary cost estimation. Based by these four models in and compiled in the significant automated feedback, then we got the preliminary concept, basic concept design. Then next one is there is this analysis, simulation, and checking building design system. You can summarize this into six subtopics, and that is analysis and simulation software, and cost estimation, construction level building model, design and document production, design review, and object models and library. The first one is analysis simulation software. All building must achieve structural terms. In a simple project, knowledge involving the system can be undergone by the primary member of design team. But in much more complex, they are handled by a consultant with building analysis software help. As we can see, that calculation in complex building cannot be undone undergo in just one night by one team. So they need a tool that to help them software, and with software the method cannot be undergone just by one night. Also, it can be weeks, even months, with reviews and redesign, of course. So this software helps them very much. Imagine without the system in the traditional method, I think they will use the much more practical way in designing, such as with empirical formula, but the outcome of the building will be not to the maximum efficiency. Okay, as you can see, here is the Tekla structural designer for determining workload in building walls. As you can see, there's walls with workload indicates by its color. As you can see, red is 109 kilonewton per meters and goes on into a purple color. And this is a Tekla structural designer. And there's much more software such as SAP and ETAPS for building and much more. But I will only use one instance in this analysis simulation software because it's pretty much the same one another software. And the next is the cost estimation. The importance of cost estimating is to enable engineers to do value engineering when designing. Alternating cost in the early design stage eliminates the traditional design method, which changing the design in the building stage is one of BIM's advantage. With modeling software, any building components will automatically be counted. Thus, local unit prices can be found and cost estimate quickly. Traditionally, the cost estimation is counted manually, but with this BIM method, we can count it automatically, and the faster the count undergone, the more like alternatives will be given because there's much more time in estimating costs for a building. Okay, so this is one of the cost estimation made by Revit software. As you can see, there's this count of, let's say, chair components, how much the chair components is there, and how much does it cost. Let's say in the dollar, $250, and so on. Okay. Next is construction level building model. Almost all tools to produce building model supports 3D component representation and 2D schematic detailing. Let's see, there is this Trimble for 3D model. There's this 2D for detailing. And then there's this design review. Almost all BIM system involves support to review model and markup online drawing. All software relies on the same format, so it can be opened via 3D viewer program. Let's say web conference. In this case, online viewer, so anyone in charge can review and give markings to any object to be changed or redesigned or reviewed. Let's say there's this beam in building that needs to be revised and changed because of its inefficiency or because there's miscalculation. So the one that checks it can check the object, in this case the beam, and then this revision should be changed by the one who made the model via the 3D viewer, in this case web conference. Okay, let's see this constructible process. The Trimble Connect is one of the web conference for building review purpose. Next one is object models in library. In 3D modeling software, there is available feature to automatically construct and adapt any construction components into part of building model. This feature varies from count, beam slab making and slab making, reinforcement, roof truss, etc. If you want to make a reinforcement, they can automatically make the reinforcement. Let's say 3 reinforcement in one beam. If we click the beam, they will automatically be reinforced. Whereas if we use CAD, we have to manually draw it, and it takes a long time. Because when you do it automatically, or if you draw it in 2D for one beam, maybe that's not a problem. But if you do it for the whole building, there will be time consuming. And if you do it automatically, it will be like not less time consuming and can be reviewed much more. So the design will be, let's say, consistent. Then these object models in the library can be seen in Tekla structures. This red part that I have lined it with red line. The object library available on Tekla structures. Okay, and then there is this BIM justification for design practice, which can be summarized for three can be summarized to three subtopics. There is this BIM justification, training and deployment, and phase utilization. Sorry, there's this ikhtisar project. This is template from presentation template. I forgot to erase it, so I beg your pardon. Let's continue. In designing a building model, of course, there's a treat for that. I mean, not all things can be received for free because BIM usage involves many aspects and team components to develop such model. A designer must allocate cost needed for two major services. There is this design concept development and integrating design with construction. So in today's model for using BIM, a designer must allocate cost needed for these two major services. Because as we can see from the McLean graph, the design process showed by line 3 will be distributed to line 4. And that distribution will distribute also the cost of the building process. So it should be considered by a designer. Okay, so that is this BIM justification. Next is for the training and deployment. BIM is a new coming in IT environment, which needs training, system configuration, template and library configuration, design review adaptation, approval procedure, etc. This needs to be developed gradually alongside existing production method. So, so not affecting today's project completion. Let's just say if we adapt it totally and do it in a short time because we wanted to implementate BIM concept, but not with right treatment. Today's project completion will, let's say, interrupted because too much information taken, and the adaptation will be, let's say, not taken seriously because it's just like some kind of formality because we have to make BIM as our concept. Because of the too fast training, the BIM will be considered as just formality for us to adapt and have BIM for constructing method. But when we adopt it with, let's say, slowly and gradually alongside the existing production, the information will taken seriously. The designer should be easy to undergo the procedure that BIM uses. One of the training and deployment that has been undergo is BIM Tekla building training held by Ministry of PUPR at Diponegoro University. As we can see the picture in the left side, which is held in the Diponegoro University. Okay, this is one of the training and deployment. Gradually, the training and deployment not directly to the designer, but to the future designer or the future engineer, so they will understand the future needs for BIM because they will adapt from early information and what the country needs from construction. Yeah, so there's that. And then there's this phase utilization. To utilize BIM usage needs some phase utilization, such as integration with cost estimation to allow continuous tracking throughout project development. And then second one, integration with specific cautions for better information management. And then this design level integration with performance analysis for energy, airflows, and lighting to address issues only considered intuitively up to now. And then development of proprietary company libraries of detailing, room configurations, and other design information to facilitate the transfer of specialized staff knowledge to corporate knowledge. I think that's all for me. I'm sorry if there's misinformation. This presentation summarized my essay briefly, so I hope that this presentation gives information needs in understanding my assignment. That is all from me. Assalamualaikum warahmatullahi wabarakatuh.